So I understand some people might not be finished 11E.1, that's fine. We will start with this. I'll go through the notes here for 11E2, then I'll kind of come around, check where everyone's up to, how everyone's feeling, and we will definitely move on today from 11E2. So just a quick recap, what we've definitely seen in previous years, and hopefully you've seen so far already, is we have y-intercept form of the equation of a line. Okay, so we always express this as y equals. Okay, if we have y by itself, that's y-intercept form. And this is great because it shows you two things. It shows you the slope, which is m, and the y-intercept, that's the point where it crosses the y-axis, which is c. So remember, slope is a measure of steepness, shows you the slope and the y-intercept. This is general form. And this is generally considered a good form for graphing an equation in. And it's in general form if we have the x and the y on the same side, and then the constant term on the other side. Now this capital C is not the same as this lowercase c. Okay, so this is not the y-intercept. It doesn't show you the y-intercept. You need to perform a few further calculations to find it. Okay, so a point is going to lie on a line. What we're assessing, right, if we have a Cartesian plane and let's say we have the equation of a line, we're assessing whether a coordinate lies on the line, okay, like that, or off the line. Now, a coordinate will lie on the line if it satisfies the equation. So all we need to do is take these coordinates. Remember, we have the x coordinate first and the y coordinate second. And we're going to put those into this equation. This is the equation of the line. So we're going to put 2 where the x is and 3 where the y is. So let's write that out. We would have 3 equals, 3 goes where the y is, half multiplied by the x value. Our x value is 2. And then we'll just process this a little bit. So the left-hand side stays as 3, there's nothing to change there. On this side we have half of 2, half times 2, that's going to be 1. 1 plus 2 is 3. So here we have the left-hand side equals the right-hand side. We have 3 is equal to 3, they're the same value. Therefore, yes, this coordinate lies on this line. Okay, so yes, we can affirm this is true. So this one was in y-intercept form. We can see that y equals m, the slope is half, the y-intercept is 2. Okay, let's move on to the next one. Question 2 here. This is in general form because we have the x and the y on the left-hand side, and then we have the constant term on the right-hand side. So what I'm going to do, I'm going to put 3 where the x is, and minus 2 where the y is. So what we'll have is we'll have 3 times 3, 3 where the x is, and then we have take away, and now the y value is negative 2. So what that means is we're going to have take away negative 2. All right, so that minus, that stays there, and the whole y value is minus 2, and then we have equals 5. And then let's process this. 3 times 3 is 9. Then we have take away negative 2. That becomes plus 2. All right, when you have 2 negatives next to each other, they will become a positive. 9 plus 2 is 11. Okay, now, is it true that 11 is equal to 5? No, they are not the same number. Therefore, this coordinate does not lie on this line. Okay, here it does because both sides are the same. Here it doesn't because they are not equal. All right, so let's start with that. If there's anyone got any questions about that. So again, we're flicking to the back of our notes book where we have the old hazy questions.